Welcome to Brain Vision.
In this problem, we have 4 balls which each have identical mass. The balls travel with given velocity and strike each other, and we wish to calculate the velocity of each ball after the first 3 collisions. We are also given the coefficient of restitution. For the collisions which will occur in the following sequence, the first collision is when ball B strikes ball C. Now, if we take the right direction as positive and we use the conservation of momentum, we know that mv, the initial velocity of ball B, remember ball C is at rest here, is equal to the momentum that ball B has after the collision plus the momentum that ball C has after the collision. That's mvb plus mvc. So we can see here that the masses are identical, so they cancel. And so the initial velocity v is equal to the velocities after the collision vb plus vc. Now, if we take the coefficient of restitution, again we take the right direction as positive, we know E is given as 0.5, and E is simply Vc minus Vb all over the initial velocity v. So from here we can see that after the first collision, after B strikes C, ball C moves with velocity 0.75 times the initial velocity v, and that's to the right. And ball B moves off with velocity 0.25 times initial velocity v. So that's the velocities after the first collision. Now the second collision, immediately after B strikes C, then ball C will strike ball D. And again, we'll apply the conservation of momentum. So C is moving with momentum m times its velocity 0.75 times v. And after the collision, the momentum of the system is that due to ball C, which is mvc plus mvd. So these are the velocities after this collision. Now again, if we apply the coefficient of restitution, so essentially we have an equation here with a few unknowns. And if we divide both sides by m like we did before, we get 0.75 v is equal to vc plus vd. And again, if we apply the coefficient of restitution, E, remember, is 0.5, and again this is vd minus vc over the initial velocity 0.75 v. So again, we have a system of equations which we can solve simultaneously in terms of v, and we get that vc is equal to 0.1875 v, and after the collision, D moves off with velocity 0.5625 v, and these are all to the right. So essentially, if we know the initial velocity of the system, we can calculate the velocities of each ball after each collision. Now the third collision, the final one in this case, is when ball A strikes ball B. Now again, we'll take the right direction as positive, and we'll apply the conservation of momentum. So the initial velocity of A, mv, plus the initial velocity of B, m, into 0.25 v is equal to the momentum of A after this collision, mva, plus mvb. Again, we have identical masses on either side of this equation, and so we can write this as v plus, so essentially we can write v plus 0.25 v as 1.25 v is equal to VA plus VB. So we have an equation here with essentially two unknowns. And again, we'll apply the coefficient of restitution. E is equal to 0.5, and the relation relating the coefficient of restitution to the velocities, E is equal to VB minus VA over V minus 0.25V. And so we end up with velocities after the third collision. So the final velocity of B is 0.8125V, and the final velocity of VA, is equal to 0.4375 times the initial velocity V.